when we get to secant, we can do the exact same thing. Okay, this one's a little bit harder actually. We're gonna end up with x equals secant y. Okay, we're gonna write in the opposite form using secant instead of arcsecant. We end up with 1 equals, the derivative of secant is secant y tan y. Okay, so then times y prime. So solving for y prime, we end up with 1 over secant y, which we're going to replace with an x, and tan y times tan y. Well, we saw before that secant squared x equals 1 plus tan squared x. So we're going to say that secant x is equal to square root of 1 plus tan squared x. Okay, so we're going to replace secant y with x, and we're going to replace the tan with 1. Oh, sorry, we're going to switch that around, aren't we? Sorry, my mistake. So we're going to say that tan squared is going to be equal to that. Okay, so tan secant squared x minus 1 equals tan x. Okay, so we end up with that expression. So this is going to be replaced with tan y will be secant squared y minus 1. Replace that with x. We end up with x square root x squared minus 1. And so why this relates, this integral then, and this is one I'm not going to really use, well, you don't need to know for for calculus, for AP Calc. But again, this one does exist. If you see ones in this form, okay, we don't need to use substitution or anything. This is just a known integral of secant, the arcsecant of x plus c. Okay? So again, if you want to put this one in your formula sheet as well, this one doesn't show up that much. I haven't seen that one in the AP Calc. So we don't need to actually know a whole bunch of different ones, okay, because these ones are related. Okay, so if I know the inverse sine derivative, really I have the inverse cos. If I have the inverse tan derivative, I don't really need cotan. I can just use the inverse tan, the negative of inverse tan. Same with the cosecant secant. If I know the inverse secant derivative, I know it's the opposite of the cosecant, because when I differentiate these, really that just becomes, those are just constants which disappear. So the derivatives of those are equivalent, except one is negative and the other one would be positive. Okay, these are how complementary angles are related. And we saw that here with the inverse cosine function. It really was just the same as the inverse sine function, but negative. Okay, so that helps us not have to worry about a whole bunch of different integrals. Okay, so let's differentiate these ones. Okay, we're going to find the derivative of this. So y prime is equal to, for the derivative of cos is going to be 1 over the square root of 1 minus x squared plus 1. Okay, it's going to be the negative version of that, times 2x using chain rule. So simplifying that, I'm going to end up with negative 8x over square root 1 minus x squared plus 1. Sorry, squared.